Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 18.4, which is going to deal with the volume of spheres. So for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to find the volume of a sphere. So we're going to talk about our last 3D shape and how to find the volume of it, and today we are talking about spheres. So we're talking about essentially a ball and how we're going to go through and find the volume of this shape. So that's what we're going to look at today. And then after we talk about how to find the volume of a sphere, we'll also take a look real quick at how to find the volume of a hemisphere, which is half of a sphere. So a sphere and a hemisphere is going to be our focus for today. So let's first take a look at spheres. Now to find the volume of a sphere, we are going to want to use the following formula. V equals 4/3 pi r cubed. So we're going to do 4/3 times pi times the radius cubed. That means for every sphere, what we need to look for in every sphere is figure out what the radius is. If they tell us the radius, then we just need to plug that in for r. If they tell us the diameter of the sphere, we just have to take that diameter, divide it by 2, and then we can figure out the radius, which that will allow us to figure out the volume of that sphere. So all we need to know today is the radius, plug that into the formula, and calculate from there. So with that said, let's go ahead and jump into example 1 for today. Now, example 1 just wants us to go through and find the volume of the following spheres. They ask us to leave our answer in terms of pi and round to the nearest tenth. So we're going to leave an answer with pi, not multiplied in, but on the out. And then we're going to multiply pi in and round to the nearest tenth. So, for example 1, part A, they give us our sphere right here, and because this dotted line only goes halfway across, it's going from the center to the edge, so that tells us that our radius is 2. Okay, if your line only goes halfway across, they're telling you the radius is 2. If it goes all the way across, like in D, that means that is your diameter. So you have to divide that by 2 to figure out your radius. So, for example 1, part A, we know our radius to be 2. If we know our radius to be 2, we can use this V equals 4/3 pi r cubed to figure out the volume of the sphere for A. So, 4/3 pi r cubed. That's what we're going to use today. All right, we know r to be 2, so we're going to plug 2 in for our radius. So it becomes 4/3 pi 2 cubed. All we have to do is just go through and plug it into our calculator to figure out what our volume is. First thing I'm going to do is evaluate this cubed. So we're going to do 2 to the power of 3. So 2 to the power of 3, and that gives us 8. We're going to multiply 8 to the 4/3, so times 4/3, and that gives us 10.6 repeating. So we have 10.67 pi. So that's our answer in terms of pi. And if we want to multiply pi in, so times by that 3.14. Oh, I hit it twice. We get 33.52. And they wanted us to round to the nearest tenth. So that's 1 decimal place. So this just becomes 33.5. And that is the volume of the sphere for part A. And that's how you find volume of a sphere. Figure out your radius, plug that value for r into your formula, and then just go through and calculate. So to give us one more just to reference and just to run through and practice it, if we look at B, they tell us our radius is 19.9. So we know r equals 19.9. So if we take that 19.9 and plug it in for r, for our volume formula, we get 4/3 pi times 19.9 cubed. All we have to do is just calculate away. So we're going to do 19.9 to the power of 3. And we get this lovely fun number, which is 7,880.599. We're going to multiply by 4/3, and that gives us, what is it, 10,507.46. So this becomes 10,507.5 pi. So that's our answer in terms of pi. And then we want to go through and multiply pi n, so times by pi. And we get 33,010.2. And that tells us our volume for part B. And finding the volume of a sphere is just simply that. Figure out your radius. Once you know your radius, plug it into 4/3 pi r cubed, calculate away, and then that will tell you your answer. I suggest you always evaluate the cubed. So 19.9 to the power 3, to the power 3, then multiply the 4/3, so that will tell you your answer in terms of pi. Then you can multiply pi n to tell you your decimal. Alright, so that is how you find the volume of a sphere when you know the radius. Now, like I said, sometimes they won't tell you the radius, but they'll tell you the diameter. You should be well practiced now, after talking about volume and area of different shapes, that when you are told the diameter, how to figure out the radius. So for D, they tell us our diameter is 16. So that means our radius is 8. It's just half of 16. For E, they tell us our diameter is 17.6. So that means our radius is 8.8. And then the last one for F, they tell us our diameter is 5.4. So that means our radius is 2.7. So if you are told the diameter, divide it by 2, and that tells you your radius. If they just have the line going partway across, that means that they are telling you the radius right off the bat, and that's what you want to use for your value of r. Once you know your radius, you just go like with parts A and B, plug that in for r for the 4/3 pi r cubed, and then just use your calculator to figure out the rest. So that is it for example 1 on finding the volume of a sphere. Now, before we wrap up today, I do want to take a look at hemispheres. So hemispheres are very similar to spheres. Okay, all we're doing is really just halving the formula of a sphere. So a hemisphere is half a sphere. So instead of 4/3 pi r squared, it's now 2/3 pi r cubed. Okay, so instead of a 4, we've reduced it to a 2. So to find the volume of a hemisphere, it's 2/3 pi r cubed. If you know your radius, plug that in for r, and that will tell you the volume of your hemisphere. If they tell you the diameter, divide it by 2, then you can plug that in for r to figure out the volume of your hemisphere. So to kind of go through and practice for example 2 on finding the volume of the hemispheres, if we look at A, they tell us our radius is 7. So we know r to be 7, so we're just going to plug 7 in for r. So that's V equals 2/3 pi r cubed. And we know our radius to be 7, so it's going to be 7 cubed. So once you have that all plugged in, all you have to do is just go through and calculate it, much like we did in example 1. Now for B, they tell us our diameter is 34.6. So you just have to figure out your radius. So we're going to take that 34.6, divide by 2, and that tells us our radius is 17.3. So once you have your radius, all you have to do is just plug it in to the volume of a hemisphere, which is 2/3 pi r cubed. So it's going to be 2/3 pi times 17.3 cubed. Now that you've got everything plugged in, just type it into your calculator and go through and figure out your answer in terms of pi, and then plug pi into that and figure out and round to the nearest tenth. So for part A, in terms of pi, it is 228.67 pi. And then if we multiply pi in, we get 718.4. So that is the volume of our hemisphere for part A. For part B, just to kind of run through it on the calculator, we're going to do 17.3 to the power of 3. And we end up with 5,177.7. We're going to times it by 2/3. So that's going to give us our answer in terms of pi. So it's going to be 3,451.8 pi. If we times pi in, we get 10,844.2. And that is the volume of this hemisphere when we plug pi in. So we've run through examples on how to find volume of spheres using 4/3 pi r cubed. We've talked about hemispheres using the 2/3 pi r cubed, and that's really kind of the main gist of our notes for today. Now, example 3 wants you to go through and find the volume of composites. So we've talked about finding the volume of a lot of different shapes: prisms, cylinders, pyramids, cones, spheres, hemispheres. You would kind of use all that here to help you go through and figure out these composite volumes. For example 3A, you would want to figure out the volume of the cone and the volume of the hemisphere and then add them together. For B, you want to figure out the volume of the cylinder, the volume of the hemisphere, and then you would subtract those two numbers. Now, I'm not going to run through all of these ones step by step because we've had plenty of practice on finding volume of all these shapes. So just to give you a refresher, the volume formula for a cone is 1/3 pi r squared h. So you have to know the radius of the cone, which is 5. You have to know the height, which they don't tell us the height, they tell us the slant height. So you have to use the Pythagorean theorem to figure out your height. So you would plug that in for h. So that is how you find the volume of a cone, which if you went through and did all that, you would get 314.2. Then you would need to figure out the volume of the hemisphere. And we just talked about how to find the volume of a hemisphere using 2/3 pi r cubed. We know the radius to be 5, so we can plug 5 in for r. Once you calculate that all out, you get 261.8. So once you have the volume of the cone and the volume of the hemisphere, because we're adding a hemisphere on top of a cone, kind of like an ice cream cone, you just have to add those two together, which is going to tell you your total of 576 for your total volume. So I'm not running through plugging everything into the formulas or figuring out the value of h. You would use the Pythagorean theorem to figure out h. So you would do 5 squared plus h squared equals 13 squared to figure out h. Then you can plug that in for your cone to figure out 314.2. Now for part B, it's a hemisphere removed from a cylinder. So you'd have to figure out the volume of the cylinder first, and you're going to use that pi r squared h. They tell us the height of the cylinder is 3.5, and they tell us the diameter is 7, so that means your radius is also 3.5. So you know your radius, you know your height, you plug all that in for your cylinder, and you get a total volume of 134.7 for the cylinder. Then you would have to figure out the volume of a hemisphere, which again is 2/3 pi r cubed. We know our radius to be 3.5 because that's half of the diameter of 7. And when you plug all of that in, our volume for the hemisphere ends up being 89.8. And because we are removing the hemisphere from a cylinder, that means we need to subtract 89.8 from 134.7, which will give us a total volume of 44.9. Now, I know I just breezed through example 3, but like I said, once you refresh your memory on the formulas for the volume of cones, cylinders, and hemispheres, we've had plenty of practice plugging everything in and calculating it out. So I don't think I needed to spend the time on just typing away on my calculator. You just have to know your radius and your height, and then you could plug everything into the two formulas, calculate it out. A, you add them together. B, you subtract them apart. So, with that said, that is it for our notes today on section 18.4, dealing with the volume of spheres and hemispheres. Remember, hemispheres, when you go through and find the volume of a hemisphere, you want to use 2/3 pi r cubed. If you're wanting to go through and find the volume of a sphere, you want to use the 4/3 pi r cubed. Sphere, 4/3 pi r cubed. Hemisphere, 2/3 pi r cubed. Find your radius, plug it into your calculator to figure out your volume. So, with that said, that is it for today on 18.4 Volume of Spheres. Thank you guys for listening. I hope this was helpful, and I hope you feel comfortable with the material and content for today. As always, if you have questions, whether on the notes or on the homework, please do not hesitate to reach out and let me know. I'll be more than happy to help however I can. So just let me know if you need help, either next time you see me or shoot me an email, and I will get back to you and help you with that. So, good luck on your homework. Be sure to reference back to the video or my completed notes. Otherwise, have a great day, and I will talk to you guys later. All right, bye.